Okay, we can finally do this properly. Hi guys, welcome to Homewreckery. It's important to keep in mind that this talk is going to be a pretty basic introduction to soft circuits, as in, would you like to build your own soft circuits and you haven't got the faintest idea of how to get started? If that's you, this talk is for you. My name is Eli Skipp. I'm a member and erstwhile director of Chicago's hackerspace Pumping Station 1, which is an organization which actually has two other members speaking here, those being Nikki and Euless, aka Rogue Clown, who's out there. Her talk's coming up in 2 hours, and Sasha, who did the chemistry talk right before this one. So huzzah to them. We're rolling deep. It's exciting. I'm a fine artist, an ex-visual communications person, a writer, and as is pertinent to this discussion, a fibers artist. I've been doing clothing construction, embroidery, pattern building, all that sort of stuff for about 10 years now. But I only recently got started doing electronic clothing thanks to two people, those being Jordan Bunker of Two Hands Project fame and Jeff Comperick. They've been my collaborators on these projects since summer of last year, and without them, most of my projects would have probably exploded. So, here's a quick breakdown of what you're getting yourselves into for the next hour or so. I'm going to give a short anecdote about how I got into all of this in the first place, and then I'm going to move from there to materials you should probably keep handy for your projects, and then on to some tips and tricks, pro tips, if you will, and that's also that your projects don't drive you crazy, all figured out at the expense of my own craziness. And from there, time allowing, I'll show you some easy-to-do homebrew projects, and then quick note, if I talk too quickly, someone make like really frantic football hand motions at me, and I'll slow down. Good to know. Okay. Onward ho! Last summer I began making a jacket. It had been a while since I built a proper piece of clothing, so I took an old jacket, I cut it up, I remade it into a marching band shrug, because I'd wanted one for a while, and I spent a week embroidering the PS1 logo onto the back. That's about this big, by the way. It's a big thing of embroidery. And that's painstaking and time-consuming work. And after a week of doing that, I sat back, enjoyed a job well done, until one of our members said, "It's cool, but what else does it do?" Sure. So I sat around and sewed a bunch of LEDs in the back, 96 to be exact, with conductive thread that Jeff loaned me. And someone else came up to me, looked at me sewing, and said, "Oh, it's got LEDs in it. It's cool. What else does it do?" So I sewed in a Lilypad to get the LEDs to change patterns, and then while I was doing that, I had to sew in a flex resistor as well, because someone came up to me and once again said, "So it's got LEDs and a microcontroller. What else does it do?" We've got really ambitious members. That made me really sad, because as you can imagine, that all turned out to be way too much for me for my first electronics project ever. I rewired those 96 LEDs 3 times and never got them to work once. Until Jordan took pity on me and made me a new 20 LED circuit before I cried. I ended up supergluing my thread to my Lilypad in a desperate attempt to get it to work. Don't do that. I then had to remove it all together, and it's only got one flex sensor now, but how excited I was. Okay. That project was a lot of learning through failures, but I suppose that's an invaluable process to go through. And it helped me create the following inventory of stuff to always keep around. So first of all, conductive thread. I see you've got a Lilypad blinking there. I'm sure you know a lot about this stuff. Yeah. This stuff is generally made up of a mix of cotton thread and silver and copper alloys. Sometimes it'll be made with synthetic fibers, but I don't like that stuff since cotton is far less flammable than polyester and doesn't get all melty. It comes in 2 different thicknesses, those being 117 by 17 ply, which is about the thickness of regular thread, and 234 by 34 ply, which is about the thickness of embroidery thread. I'll be honest, I absolutely hate this stuff. It is my least favorite thing in the whole wide world, but it is a necessary evil. The problems with conductive thread are trifold: massive fraying, high resistance, and janky connections. 2 of these, and you can guess which ones, can be solved with Fraylock, conductive glue, and super glue. Super glue is my not terribly recommended cure-all. While that solves the fraying and connections issues, do I have a mouse anywhere? I do. Okay, while that solves the fraying and connections issues, you're still stuck with the resistance problem, and that's a lot more difficult to overcome. Conductive thread has about an ohm of resistance per inch, and that builds up really quickly when you're sewing. and that can cause a lot of problems. So my best advice is to really plan out your circuit beforehand, before you start sewing, and try to make it as economical as humanly possible. And then whenever possible, use the thicker ply thread. It has much lower resistance. And Jimmy, Nikki, and Jordan advised me that this is because there is more electricity, more area for the electricity to flow through, because, and to quote, you're going to get a lot more resistance going through a tiny tube than through a big honkin' pipe. And because, again, and to quote, electrons are stupid. You can buy spools of this stuff between $20 and $30. Yeah, okay, $20, $30 from sparkfun.com, or about the price of a VCR. So again, I get mine from SparkFun. Yeah, it's Cleveland. Come on down to Cleveland. That song's been stuck in my head for 4 days. I can't stop singing it. Okay, I get mine from SparkFun. You can also get it from plugandwear.com and a number of other places. But here's a link to an Instructables tutorial on how to make your own conductive thread for all of you overachievers. Second thing I want to mention, conductive fabric. If you've ever met me before, you've probably heard me wax poetic about conductive fabric. This stuff is magical. Wherein conductive thread has failed me time and time again, conductive fabric has made me want to wrap myself up in its cold, steely embrace and drink a glass of wine to celebrate. This stuff comes in all sorts of types: stretchy, non-stretchy, mesh, non-mesh, various metals and metal alloys, various fabric types. You can buy it from more conventional places like plugandwear.com, but the best place to buy it from is lessemf.com, a company lovingly known by its patrons as the tinfoil hat guys. Conductive fabric is primarily made to be a shielding material. If you wrap your cell phone in it, you'll lose signal. It blocks X-rays, which has led to some really awkward questions in international airports, and some awesome plans for conductive fabric pasties for all you modest people who dislike full-body scanners. People buy it in large spools, and they coat entire houses in it. This is why, thus, tinfoil hat guys. My uses for it aren't so grand, alas. I primarily purchased copper polyester taffeta, which is one of their cheapest fabrics. It's flexible, sewable, solderable, and best of all, has a magically low resistance, especially in comparison to conductive thread. The resistance is less than 0.05 ohms per square inch. I already told you where to purchase it, but just in case, here's the link again and a tutorial for building it. I should probably tell you now that I will have a link to this slideshow up on my website, which I'll link at the end, so no need for frantic scribbling. Next thing, conductive glue. If you're using conductive thread, you're going to need this. Again, I tend to use super glue, but I'll bet I shouldn't be doing that. Conductive glue, then, is going to be your lifesaver when you notice all of your janky connections are only working when you pull your fabric in a certain direction. You're going to glop it on like makeup on a lady of ill repute. And your circuit is going to like it, like the lady of ill repute that it is. Luckily, you can make yourself a large quantity of this stuff and make it as viscous or not viscous as you'd like. Here's an Instructables link again. But conductive glue is essentially just powdered graphite, which you can buy in bulk, like huge quantities of the stuff from art supply stores, and liquid tape. That's all it is. Alternately, you can buy it from electronics parts shops and American Science and Surplus, which is like the god of all stores. Another upside to conductive glue, it can be used like conductive paint if you want to make conductive fabrics and papers. That's really how Instructables tells you how to make conductive fabric. Just slop on conductive glue and sew through. Lilypads and associated components. You can't get through a talk about soft circuits without hearing about these. These aren't really absolutely necessary, and you're not going to turn to them every time you start a project, but they're great to have around. I've had a less than ideal experience using them. See, again, janky connections. They're gorgeously designed and well adapted to soft circuits, though, seeing as that's what they're made for. Should your projects graduate to the realm where they require microcontrollers, you're going to be ready to hug Leah Buechley and kiss her square on the mouth. You may still be inclined to do so even if you're not in need of an Arduino, seeing as Ms. Buechley, thanks to Ms. Buechley, there are some really gorgeous and sewable components that might do you some good, like vibration pads, accelerometers, battery packs, really cute, teeny tiny switches. Look how small that thing is. It's really cute. I'm assuming that pretty much everyone knows where to buy those, so here's a really awesome link to this circuit layout tool made specifically for Lilypad and Lilypad components. I highly recommend it. Fashioning Tech is also an awesome website for pretty much anything fashioning technology related. Love it. Okay, other things that are like fun, you don't have to have them, but you should keep them around for fun and easement. This is for electronics and for sewing. I'm not sure how many people here actually sew, so it's a good thing. Blinkies. I always keep around a ton of LEDs because they're such an easy and fun thing to use and play with. Even if you're not aiming to use LEDs and make your things all shiny and fancy, they're really good indicators of a working circuit. Other random components. That's one of the many messes I've made at my hackerspace. I've got at least 50 photos of these, but that one was kind of clean. Keeping some weird bits around is a really good method of working your improvisational creativity, if you will. My friends who work with electronics more than I do tend to build their projects on a whim, out of scrounged parts, which is a really admirable quality that I'm not quite up to yet. Let's say you had tiny speakers lying around, some servos. I'm sure you could think of something really awesome to do when you have free time, unlike myself. A random and unexpected acquisition of this really cute, tiny microphone has spurred this awesome idea for a jacket that lights up when you talk for a friend of mine who does a lot of games and things. So hopefully that works out. Exciting prospects. A sewing machine. This is actually the model that I have. Lots of people don't have sewing machines and have no idea how to use them, and I think that's kind of a shame. I think everyone should know how to sew and how to use a sewing machine. I suffer when I don't have one. I made my parents bring one in a rolling backpack up from Miami through TSA because I suffered without my sewing machine. Granted, with conductive thread, your uses for a sewing machine tend to be more minimal, but later on in this talk, I'll give you an example of when my sewing machine would have been my best friend in the world. If you want a sewing machine but are worried you can't afford one and Craigslist and eBay aren't doing it for you, you can... Thanks. Okay. Okay. If you need a sewing machine and you're not sure you can afford one and Craigslist isn't working out for you, Sears will sell you one that was taken back by a person who had it for a day and realized that they hate sewing. You can get them for about 60 bucks, essentially brand new. Not sure how to use a sewing machine? Joanne's teaches classes, and you can bet your boots there's a Stitch and Bitch around in your city that will very happily tell you how to use it. Again, everyone should know how to use a sewing machine. It will change your life, save you money, and empower you in a weird way, Scout's honor. An embroidery hoop. This will help you get tighter, more consistent, and less frustrating stitches when sewing by hand, which is really helpful for all that conductive thread and your janky connections. That's the theme of my talk now, isn't it? Janky connections? Yeah. Anyway, they cost about 50 cents and come in a million sizes from like this big down to this tiny. And they're indispensable, no lie. If you've never used an embroidery hoop, try it once. It'll make you feel a lot better. Seam ripper. This will also make you feel a lot better. Even the best seamstress in the world makes myriad mistakes, and there's no shame in that, but there is a lot of satisfaction in ripping those mistakes out. When I teach people how to sew, the seam ripper is always the first tool that I teach people how to use. Various sewing supplies, not going to go into detail, pretty self-explanatory and obvious. You know, keep a couple needles of different gauges, some thread, different sizes of thread, fabric, pins, chalk pencil, you get the idea. Okay, enough with material things. Here is a list of tips and tricks to keep in mind. 1, always have a friend who knows more about stuff than you do. Failing that, always have the internet, which is full of people who likely know more about this stuff than you do. As with pretty much anything, your most indispensable resource is going to be the wisdom of people who've been there and done that. Even besides that, it's great to have someone around who can point out your silly mistakes and remind you that you're never going to be done learning. Those are all my PS1 buddies. Look how cute they are. Aw. Oh, that's a terrible picture. Okay. If you don't have one yet, get yourself a rudimentary knowledge of electrical engineering. By rudimentary, I mean learn the basics about resistance, understanding the limitations involved with there being a positive and a ground, learn how to use a multimeter and a soldering iron and a power station and a breadboard, and get used to the smell of burnt parts. Audit a college course if you have to. You're going to have a lot of fun doing it, and by rudimentary, I really do mean rudimentary. What I know about electronics is novice at best, but it gets the job done when used in conjunction with that first indispensable resource I mentioned. What's a good way to get started? I don't know if you've heard, but there's a bundle of workshops here. Go learn from your fellow hackers. I know I'm doing that. This is a good one. This is part of how I really wish I had a sewing machine and knew what I was doing when I first started one of my projects. I'll give you, the links will be up later, I promise. I built this project called a fabric light bright, which I'll be showing later because it's an extremely simple project to get started with. But the top layer of it is just multiple tons of lines sewn on this big piece of fabric using conductive thread. And I did it all by hand. It was all hand embroidered. It took me about a week. And I realized right after that I could have just done it using this. This is called bobbin work. Bobbin work is sewing upside down, essentially. You wind a bobbin up with whatever thread you want, embroidery thread, yarn, ribbon, conductive thread. But you have to hand wind it, which is not so good. But it's a really handy trick. Just load your bobbin in, sew like you regularly would, and all your conductive thread is in its fancy, janky connections. No more. It's done. It's solved. All right. Yeah. So I really recommend using this. It's the only way I'm able to teach workshops using my fabric light bright. Remember this trick. Okay, this is another Leah Buechley trick. If you want to sew in resistors, LEDs, capacitors, whatever, grab a pair of needle nose pliers and curl the ends of your components. That's how you sew them down. And then a big mistake I made, if you have a positive and ground that actually matter on your components, don't curl both sides in the same shape, because you will forget what's what. Curl one side square. I made that mistake, and my friend had to make me this fancy little box that I could push down on my LEDs so I knew I was putting it the right way, and that took me an extra hour. Where possible, just use wire instead of conductive thread. For my past two more complicated projects, I used flex sensors and attached those using basic wire sewn into the seams of the garment. Nobody will know it's there. You can hide them inside or be out and proud about the grittiness of your project. But you'll be happy you did it either way. It's just more resilient and less resistant. In fact, if you're having trouble with conductive thread, Jimmy Rogers, there you are. Jimmy Rogers recommends switching to 30 gauge copper wire whenever possible. I've had limited success with that method, but I'll bet it works like a dream for other projects. Would you like to actually wash your soft circuits? I'll bet you would. I get this question after every time I do this talk. And I've only finally realized how to answer it. Build your circuit into a thing that snaps on and off, or zips in and out, all these different options. A lot of you, at least be able to do it with your battery pack. A lot of those come with snaps already, but my friend Jeff really likes these magnetic snaps. They are cheap, you can get them pretty much anywhere, and they are naturally conductive and made to be sewn in, so that works really well. I've also played with the option of just literally zipping everything in one zipper, but if you don't want to look like a goth kid from the early aughts, that answer might not appeal to you. If you're snapping your batteries in and out, it's still best if you wash your garment carefully and by hand. Conductive thread is fragile, and likely your parts are too. If you insist on using a machine, at least wash them as if they were expensive lingerie and just as sexy. The delicate setting is your friend. And for the love of God, don't use a dryer. Again, based on my mistakes. When you're done washing your garment, hang it up to dry and give it all the time it needs. Oh boy, I still have like 25 minutes to kill. Hopefully I'm good. Okay, these are things you can build yourself that I'm about to show you. So we're going to move forward from your more basic info that I just gave you and all of this stuff and onto a list of projects you can build yourself given the information I just gave you. I'm not going to go into most of them very in-depth because I worry about time constraints. Oh, not anymore, I don't. Oh, yes, okay, and because the tutorials are all online and can explain them far better than I could. This is the one I mentioned before, if you can see it. It's my fabric light bright. It's really versatile, really fun to play with. I was going to do a workshop on it here until we had some issues involving sewing machines. But your options for screwing it up are severely limited, which is why I like it. It's actually been featured on Hackaday and Makescene and DIYdaily.com. I've got a PDF for it, which I guess I'll show in a second, like pictures from it. But if you Google my name, it'll come up and you can build it. I mean, it's really, really simple. It was a big honor when it ended up places. I call it the fabric light bright, but if any of you come up with a better or more witty name than it, I will send you a kit to build one of these yourself, completely free of charge, because I'm really bad at naming things. Yeah, desperate for a clever name. In a way, it's a lot like a fabric breadboard, although there are definitely some limitations there. And if you really want a fabric breadboard, you can buy one of these from plugandwear.com. It's a fabric perf board. Useful. Okay. What I would really have liked to do with this is, I don't know if you guys know about the Husqvarna embroidery machines. They're about $2,800, and you can plug in a USB key. Yeah, a lot of money. So worth it. I know, I want one. But you plug a USB key into it, and it will embroider for you any picture you want, anything. And so I want to get one, wind up some conductive thread, and use it to make printed circuit boards out of conductive thread, which, yeah, right? Right? I'm on it. If any of you guys have a hackerspace or anything that's 501c3, grab yourself one of these based on your donations and, you know, make me some, okay? Because I don't have $2,800 yet. That's right, thinking proactively. I mentioned this project before when I was explaining bobbin work to you guys, and I noted that I hand embroidered mine. You probably can't see my face back there, but I don't look very happy. This is a picture of the process, and here's a picture of what I ought to have done via the bobbin work. I know it's a fuzzy picture. Okay, to build it, you literally just sew in those lines, do it with your sewing machine, do it by hand if you want. You can make really fancy pictures, birds and things. Done that too. And then sew a strip of conductive fabric on the top and the bottom. It'll even out your voltage. And then you want to sew a piece of proper fabric behind it to separate that from your ground and your positive. And then proper piece of conductive fabric. And the way it works is your top lines are your positive, bottom lines are your ground. So you want to attach your leads this way. You can make it completely impermanent. Just stick your leads through, bend them around. I know the pictures are terrible. Bend them around. You're going to do that on the bottom too. Poke a hole through it, just stick it through. You can do it permanently as well, because again, you can solder to conductive fabric. I love conductive fabric. And the top one, you can get yourself one of those really adorable tiny switches. That's what I did with my first one, and make it permanent, but you don't have to. You can just take them out anytime you want. And then you can stick LEDs through anywhere you want, and they'll light up and make really fancy pictures. That's a diagram of how to put the LED through in the best way possible. Wind up one flat, poke it, it's all good. I've got one here with me. I'm not sure where I'll be sitting with it, though. I'll probably just have it under my arms. If you want to play with it, I'll be lugging it around as happens. Again, you want to throw one side, poke the other side through. This is my PDF. I'm not going to go through the whole PDF. Don't you worry your pretty little hearts. But it's a really better way to explain it. There's a link will be up. I guess I'll put it on my site. That's what people do. This is an easy and awesome project. It's a lot like your necklace there, but doesn't use a lily pad. I'm sorry, I'm not trying to embarrass you. I quite like it. Okay. This is just a bracelet with a bunch of LEDs in it and some conductive thread. It's a great starting point. The bracelet's clasp is made to finish the connections, so they'd recommend less EMF, tinfoil hat guys, conductive Velcro. You just stick the Velcro together, tear it apart, connections open, connections closed, everything's peachy keen. Or you can use those magnetic snaps. You can use pretty much anything you want. Most connectors that you'd use for jewelry and sewing are automatically conductive. It's awesome. So the materials you need are really few and really simple. Felt and fabric, needle and thread, scissors, conductive thread, pliers, LEDs, a clasp, and a battery. The list of supplies is on the site, and it gives you a good place to find all of the non-obvious stuff. I'm not going to go into it any more than that since I have the link. This one I really like. I've mentioned that I've used flex resistors a number of times, flex sensors, bend sensors. They're called like a whole bunch of things, but they're really great components, especially if you want to have really dynamic things that when you move around, they react. However, they get expensive. They're, I think, $15 a piece expensive for flex resistors. But you can build them yourself. That's what this is. It's built basically out of neoprene and conductive thread and some snaps, and that's it. No, it looks like conductive fabric, but pretty much only those. And the tutorial will tell you how to build this thing, how to snap it in. It's waterproof, it's washable, it's awesome, and it's removable. Rock on. You can also make this in another way that I didn't put up because I find it way too complicated, where you buy conductive yarn which they make. It's very expensive, but it's really cool. And you can knit your own flex resistor, and as the yarn is automatically stretchy, you have yourself a flex resistor. And I like these too. These are really cute ways to hold your little 3-volt batteries. They're like little merit badges for batteries. Oh God, they're adorable. This comes particularly in handy for LED projects such as the bracelet I mentioned earlier. It's got the only parts in it are 2 pieces of metal, a battery, and some felt. That's it. Much more aesthetically pleasing. I still have a lot of time, so I'm going down here. I'm going to show you 2 projects 2 of my friends did, which are a little bit more advanced, and I'm going to try to take it slowly to take up as much time as possible, because I have extra time. This is my friend Jeff Kantarek. He's Speed Racer in this picture, but before he was Speed Racer, he was a professional electronics engineer, and now he's very happily unemployed. Oh wait, no, he just got a job. He was happily unemployed. Congrats to Jeff. Now he mostly builds things with his startup company and for UFC, but he hangs around the space a lot of the time, helping everyone else, yours truly included, figure out what they were doing wrong with their electronics projects. But Jeff Kantarek is building a biofeedback shirt. It's still in progress right now, but I'd like to update you on how it's going so far. The premise of the project is to provide biofeedback in order to improve the balance of, and thus accelerate the recovery of people with balance-related issues like inner ear problems. It uses a Lilypad, an accelerometer, a whole bundle of vibration pads, and a LiPo battery, plus a bunch of conductive thread. This is how Jeff started with the project. You can tell it's kind of a mess. He had trouble with the resistance of the conductive thread and the shaky connections. Janky connections? Okay. And the frame. So he tried first to just connect it without sewing it down and then to sew it down afterwards to try to avoid some of these problems. And as you can tell, it became a giant tangle. So he had to scrap that whole idea and start over in the more sort of conservative fashion of doing these things. He switched to 117 by 17 ply and had to hope the resistance didn't add up, and that became a problem as well. And he drew up a brand new shirt, sewed on all of the conductive thread properly and less messily with the help of his mother, with fabric sewn over to allow overlapping and not mess with the ground and the positives, and the ground connections were completed. The accelerometer was attached to the analog inputs on the main Lilypad board, and a small pocket was added for the battery, and the vibration pads were sewn kind of around. These are the vibration pads sewn all the way around the waist. They're sewn on the inside of the shirt for direct skin contact, so those are actually up against your skin, vibrating, kind of creepy. So once your balance goes off center, these vibration pads buzz and let you know until you find yourself properly upright again. I mentioned this to a friend recently. He said, you know, that sounds like a cool idea, but what you should really do is use it to mess with drunks. In the end, though, Jeff came to realize that a shirt was perhaps not the best thing to mount this on, and he moved to a chest and waist strap. I'd talk about that more, but it's not really it's still wearables, but it's not conductive thread, conductive fabric wearables. His next one, however, is going to use stretchy conductive fabric. They make stretchy conductive fabric. It's great. So it's his chest strap. You can check out effectiveengineering.com. That's up there, as is another project of his, which isn't finished. He was working with my friend Yasna Delic to make this thing called Warm Strings. It's a hand-sewn scarf, and attached to it are touch pads and a lily pad and a speaker, so that when you touch it, it will play violin music. I think it's really nice, but it's still not done. Moving on. This is my friend John Stoner. We did Power Wheels racing at Pumping Station 1, just to clarify why all of my friends are riding Fisher-Price Power Wheels. John Stoner is an incorrigible member of the cycling community in Chicago and the Burners, and he's also a damn decent programmer. He created this thing called Boogie Pants, which is still in progress, but I find it to be pretty awesome, and pardon the picture quality, I wanted to take a new picture, but it's currently being borrowed by his belly dancer friend, and she hasn't given it back yet. This is really a lot different from the other projects I've talked about here. It's less an example of electrifying clothing and more an example of the awesome relationships that can happen from putting tech and soft circuits together. While Boogie Pants incorporates none of the indispensable components I mentioned in the beginning of this talk, although it could if one were inclined to get fancy, it very much deserves mentioning. It was made using the apron-like garment that I just showed you. and a Wiimote, not to mention a pretty good knowledge of Java and Wiimote hacking. I can't explain any of the background stuff to you, but luckily John can. This link will be up, boogiepants.typepad.com. He's working on a document on how to build it. Thus far, everything about it is open source, Creative Commons sort of stuff. So what does it do? John says to think of them kind of like a synthesizer. Different media events are assigned to different controls on your Wiimote. For example, a sample of tone. And even better, everything you do is controlled by dancing. That's why he's working with a belly dancer. Yeah, it's pretty great. You can't be that naked while wearing it, though. It's an apron. Sorry. It's all good. Okay, you might want to put your hands over your ears, because I'm going to show you how this is sharp movements, and they make a sharp sound. So watch out. Oh, nope, nope. No work. Come on, buddy. Oh, I'm not attached to anything, so maybe it's not going to hurt your ears. Anyway, that's all the background stuff. So sharp movements make sharp sounds. These other ones will like make regular scales. You probably can't hear that either, so I'm not going to worry about it. And then you can also do circular ones, so that's what he's got so far. These are his avatars thus far, but they're going to get bigger and fancier. I'm going to read what John asked me to say about his project. He's very excited about it, as am I, so going with his words. He wants to make a note that it is a new category of thing to use video game technology and fibers together for a musical performance in a way that enhances the interaction between the performer and the audience. So imagine a belly dancer on a stage with a garment, and the garment integrates the Wiimote and the nunchuck. There's an image of an avatar projected on a screen behind her. As she dances, the avatar moves with her, it interacts with the object on screen, and it creates media events like playing samples, scales, videos, that sort of thing, various things. And you can control it with lots of different movements. As she pushes the buttons on the sensor, sets of objects swap in and out, so your whole body is your musical instrument. It's fully open source, the code is open source, the garment designs are open source. He's really looking for collaborators, so if anyone wants to help with this, coders, dancers, DJs, 3D modelers, everyone has a place in Boogie Pants, as John says. Yeah. Boogie Pants, you've got a place in my pants. Anyway, as a note, all Boogie Pants instruments require an OSC address which defines where their signals go and when they're played. Different instrument types and different signals. All Boogie Pants signals are single floating point numbers. And here's the future he wants for it. One, it's currently based on tilt sensing, but he wants to go for full motion sensors in the future. And he says, imagine going to see Daft Punk or someone like that, and instead of standing behind a console and just kind of pushing buttons and being boring, they have to come out and actually dance around to play their music. Apparently it would be, I don't really go to any of these shows, so I don't know how boring it is to begin with. But yeah, so full body avatars, et cetera, jumbotrons, stadium shows, not just with their pelvises, but with their entire bodies. And the second thing he wants is easier programming and extensibility of visual effects, because right now there are 4 different kinds of controls in Boogie Pants, which are 4 instruments. They're cool, they have limited visual appeal and dynamicism. Imagine if you had an easy way to add new kinds of visual effects and musical events to Boogie Pants. And yep, crazy cool, crazy adorable. You can find out more about this project from boogiepants.typepad.com. And to be fair, that's really all I got to say. I'm done. That about wraps it up for everything I wanted to talk about. I guess in conclusion, I'll do questions after. I promise. Yeah, but so in conclusion, awesome things come from putting electronics and clothing together, even if all you want to do is make your clothes blinky and shiny. Hacking clothing like this will always be a valuable thing, because in the words of my first fashion teacher, clothing designers will never be out of demand because everyone will always wear clothes. Why not make ones that are more functional and fancy? I'll take questions now, but when I'm done, go build your own stuff. Swear to God. Workshops, pretty cool. And if you've done anything awesome, I really want to know. I'm always looking for more people to tell me what's going on. This is my Gmail, my Twitter, and my website. So I'll take constructive criticism, suggestions. Be nice, that would be lovely. Questions, all that stuff, all up there. Peachy Keen. Yay. Thanks.
Fabric, and instead of using the conductive thread, this is of major importance because I'm doing a workshop with a bunch of 13-year-olds on Friday.
Good
Have
luck.
you tried using conductive fabric in place of conductive thread in, yes, just bracelets that blink or whatever? Like thin twists of it or like really thin slices of it, or would that immediately have consequences?
That probably wouldn't have consequences. I've done that only a little bit, but not enough to
So if
comment
you-
on how well you could do it.
Okay.
If you're just making bracelets, try it with a conductive thread and just use a ton of glue.
The conductive thread doesn't work. We've done this once.
No? Okay, well try the conductive fabric. That stuff is
Janky
pretty great. And then, again, the conductive glue is really useful and easy to
Yeah.
make. Yeah.
The answer to 13-year-olds is conductive glue. Thank you. Okay.
Let me know how that goes.
Hi, I have a question. When you say conductive fabric's expensive, how much is it approximately per yard? I'm
Oh, no,
planning
it's
a
not-
workshop
it's-
for kids too.
It's really not that well. It depends. I've done workshops building those fabric light brights at about this size with conductive fabric and conductive thread and everything for everyone, and it only came out to about $10 a kit. But the one I buy, the copper polyester taffeta, which is one of the cheaper ones, comes in, you can buy it by the foot, but each foot is 40 inches long, and each foot is about $10. Yep, so it could be worse. They'll also do better stuff for bulk.
Have you worked with nitinol?
Pardon?
Nitinol?
Nitinol?
Memory wire?
No. I'm brand new to this. Well, summer.
How do you prevent your clothing from shorting out on other metallic items?
I've never had that problem. No. Would I? It doesn't get all staticky or anything. Most of it's severely coated in other stuff to make sure it doesn't fray anyway.
Any advice for sweat proofing? If I'm gonna dance in something like this?
If you're gonna dance in something like this, you should probably, you know how I said to snap things on and off for washing? Just do that in something waterproof like neoprene or canvas and snap it on and off because you're gonna wash those clothes.
But in low voltage, it doesn't really matter if you get it wet.
Yeah, it's not gonna shock you or anything, but you should snap it out.
Sorry, basically I'm saying that as long as the way that you've connected it has a lower resistance than what your sweat is providing, then it shouldn't be a problem, especially at low voltages. This comes into play a lot for like I do circuit bending and touch-based instruments, so like that's kind of the same thing. Like you're shorting it in indirect ways, but so blinking stuff shouldn't be affected by it that much. Yeah.
Are you dancing hard enough?
Jimmy always gives me really good advice every time I do one of these talks. And he's selling kits. He made the Blinky Heart thing.
Thanks. With regard to components, have you ever done anything that has Wi-Fi connectivity? Is there any wireless network device that is small enough to incorporate into your clothing?
I was actually asked that question recently, and I still don't really know the answer. I believe there is, but I'm still doing really basic analog stuff.
So you can use the XB for radio, or you can use the Blue Smurf for Bluetooth connection to your phone or whatever.
There's actually a Lilypads style shield for the XP now that Leah did not release, but somebody else released it. It's just it's in the same like shape as the Lilypad, and just for doing XB type stuff. So radio communication can be done. Yeah.
There are also serial to Wi-Fi transceivers that are quite small, so one of those might be adaptable. They're also expensive.
They sell really cheap stuff on eBay
I like my small onions. Are we good?